video will cover section 7.4, which is Systems of NonLinear Equations in two variables. The introduction of this chapter talks about the path of a comet. And so, as you know, some things they orbit in an elliptical pathway or shape. So like planets, right? And here's the sun. And so other things like a comet, they orbit in a parabolic path. So they do that. And so sometimes, you know, because math is actually useful in real life, some people in NASA, they use systems of equations. And I imagine that we're talking about a three-variable system because in a three-dimensional plane, right? So like what happens in space, like if something's going to collide with something else. So they're actually used, and the title of this section is Systems of NonLinear Equations. So the fact that it says nonlinear, it will include equations that are quadratic, or the equation of a circle, or the equation of an ellipse. What else do we do? Oh, and also you could have a line, one line. So the condition to call it nonlinear is that at least one of the equations is not linear. Okay. So as you know already from section 7.1 and 2, well, 7.1, the solution to a system is the intersection of the two equations, right? So let's complete this by filling in the blank. So we have a system of nonlinear equations in two variables, also called a nonlinear system, contains at least one equation that cannot be expressed as ax plus by equals c, which is the standard form of a linear equation, right? So if we call it nonlinear, at least one of them is not linear. So the solution, a solution to a nonlinear system in two variables is an ordered pair. So again, the title is in two variables, and so that's why we're talking about an ordered pair. We're not going to have a triple like we did in section 7.2. However, what I was saying, if we talk about this as a problem from NASA and, you know, like a real one, I'm assuming it will be a three-dimensional one, so three variables. Okay, so it's an ordered pair, and of real numbers that satisfies both equations. So for an ordered pair to be a solution of the system, it has to be true when you substitute the numbers. It has to give you a true statement for both equations, or three equations, as many as you have. And so the solution set of the system is the set of all ordered pairs. So we might have two solutions. So if we have two solutions, then we will have a set with two ordered pairs inside it. And that's how you will enter your answer on my math lab, actually. Okay, so we're going to look at substitution and addition or elimination method. And so for that one, if you look at them, for a card, if you know, raise your hand. What shapes are you going to get when you graph them, if we were to graph them, which we will in a minute?
Which one?
The system here. Okay. Enter.
Would it be like the top one would be a parabola and the bottom one would be a linear?
Correct. Very good. That's true. So I don't know where I put my cards. Oh, they're here. So yes, you will get a parabola. It's a quadratic, right? And the other one is just a line. So those could intersect at 1 point, 2 points, 3 points, or they could not intersect at all. So let's see what we're going to get. So since it says substitution, let's just go by that. So I'm going to take, remember how I like to number my equations? So I'm going to take equation 1 and solve for y. So we got 3x minus y is equal to 9, so that would be 3x. I'm going to take this positive 9 across, so it's going to change from addition to subtraction, so 3x minus 9 is equal to, and then the negative y is subtracting, so if I take it across, it will be adding, or positive y. So now, here, this is the expression that we're going to use to substitute, okay? So my next step is going to be to substitute y with the expression that we found, the 3x minus 9, into equation number, oh, my bad, this should be equation 2. And we're going to substitute into equation 1. Okay. So we take equation 1, which is x squared from here. X squared is equal to 2y plus 10. And if we substitute the y, we will get x squared is equal to 2 times 3x minus 9, and then we have a plus 10. So here we need to distribute the 2 and then combine like terms. So 2 times 3x, 6x, 2 times negative 9, negative 18, and then we have a plus 10. So what do we do anytime we solve a quadratic? What's the first thing we have to do?
Just combine my like terms.
Convert, take one side to 0. Yes. And so if this is 0, and combine like terms is also necessary, right? So right here, this will be, actually, let's do the following. Let's combine like terms first. So we have x squared is equal to 6x minus 8. So if we turn one side to 0,
X squared minus 6 equals 8.
yes, very good. So that equals 0. And then we hope we can factor, right? So let's do that. Minus 4, 2. And so we know quickly, right, from the zero factor property, you take each factor, and at this point you should be very comfortable doing this, right? X equals 2 and x equals 4. Yes? Are we okay with that? Okay, and so from here, what I want you guys to do while I get the image, I want you to find the y solutions. And so in this case, so I want you to do the following. So for x equals 2, you're going to use so you're going to do the back substitution in here. So y equals 3x minus 9. So then you will substitute your number there to find both. So you're going to do that twice. And then I will be getting the graph.
Do we put them in ordered pairs, like according to which x we put?
Yeah, that would be helpful. So was it the x minus y? What is it? 3x minus y. So we have this line, and we have x squared equals 2y plus 10, and the parabola. Okay, so can you guys look at the board, please? Okay, so we could see here the intersections, and so let's point them out. So we have the point 2 comma negative 3, and we have the other point here at 4 comma 3. So this is a very nice way to check your work, to see if you're missing one, or you know, you could graph them while you're doing your homework. Okay? Yes? Also, your take-home exam is going to be including Chapter 7 and Chapter 8. So, you know, make sure you use your resources wisely, such as technology. You can use your calculator, you can use Desmos, you can use whatever. So you make sure you check your work so that the graph matches your written work. Okay, so next step, or next problem. So now we have 2. So raise your hand if you know what kind of shapes you're in. Amy? And? Yes, a circle and a line, that's correct. So the second one is a circle with, where will the center be?
In the
Go ahead, Raul.
is it 2 and negative 3?
2 and negative 3, very good. Very nice. Okay, I'll give you a card in a minute. So here we have a line, and we could use substitution again. I'm going to solve for x in the quick equation number 1. So x minus y is equal to 3. So x is equal to positive y plus 3. Very good. Then we're going to substitute the x with y plus 3 into the second equation. So while you guys do that, you have to be very careful, because instead of x, you have y plus 3, but then you still have this minus 2 here, and then close the parentheses. Okay, so this is y plus 1 squared is equal to y plus 3 squared. Now, when you expand the binomials, make sure you don't just square the y and the 1, because there's something in the middle, right? When you square a binomial, how many terms do you get? 1, 2, 3, right? Okay, and so let's expand this one. So we get y squared plus, the shortcut is the product of y times 1, that's y, and then we double it. So how many y's? 2 y's. And then 1 squared is 1. Now let's square the other binomial. So y squared plus the product of y times 3 is 3y, and then we double, so 6y. And then 3 squared is 9. And that equals 4. So let's combine like terms first. So 2y squared plus 8y plus 10. And then let's take this positive 4 to the left, so it will be negative 4. And that equals 0. So here we have 2y squared plus 8y plus 6. Then we could factor out a 2 from here. We'll factor 2 from 2y squared. Remember, it's like we're dividing, right? So 2y squared divided by 2 is just y squared. 8y divided by 2 is 4y. And then 6 divided by 2 is 3. Okay. So then here we hope we can factor, right? Because we have a trinomial. So we can factor the 2 binomials. So that will be y and y. The sign is positive, so that means everything's positive, right?
Plus 3 plus 1.
Plus 3 plus 1, very good. And from here, we know right away y equals negative 3 and y equals negative 1. Okay, so I want you guys to go ahead and find the x values that correspond to that. Okay, so what could you do? You could use the substitution that we already have for x. So to back substitute, you need to do it twice, one for y equals negative 3 and the other one for y equals negative 1. And you do that in here. So we have here the graph for the system that we solved here. Well, we're actually not done solving it, but let's see. So according to the graph, the two equations will intersect at this point here, 0, -3, and the other one will be at 2, -1. So let's just finish quickly reviewing this part to see if it matches yours, and then we'll move on to the next problem. So for -3, it will be x is equal to y minus, plus 3. So that will be -3 plus 3, which is 0. So yes, that matches our graph. And for y equals -1, we will have x is equal to y plus 3. We substitute y with the -1, so -1 plus 3, and that will give us +2. So yes, that does match our graph. Yes? Okay, so do we have any questions so far about the back substitution? No? Okay. Oh, that's not it. Okay, there we go. Now, example 3, if you guys notice, it says solve the system, but on the title, right next to example 3, it says solving nonlinear system by the addition method. And so what we did in 7.1 and 7.2 was we were adding to eliminate one variable, right? And that was if they had opposite coefficients. So as long as we have that, we could combine here like terms, and then solve it, right? So we could also do that if the variables have the same degree or the same exponents. Like in that case, we have x squared and y squared. So what I'm going to do is just, I'm going to eliminate y by multiplying the second equation by -1. So the first equation is still 4x plus y squared is equal to 13. And my second equation, every single term will change to the negative sign. So -x squared minus y squared minus 10. Now here we can eliminate the y squares because they have opposite coefficients. And 4x squared minus x squared is 3x squared. 13 minus 10 is 3. And then x squared is going to be equal to 3 over 3, which is equal to 1. But then we have x squared is equal to 1. And of course, if we take the square root on both sides, we will eliminate the exponent on the left. But the right side should have two answers, and that's positive and -1. So that's 2. Positive 1 and -1. Oh, yes. So that should just be yes. And so from here, now we need to use back substitution. So if I take this equation and I solve for y, the x squared plus y squared equals 10. And then I want to solve for y, so it will be y squared is equal to -x squared plus 10. So then I will have y is equal to the positive and negative square root of -x squared plus 10. Okay. So I want you guys to solve it. So that's the rule for both. So we're going to have for x equals 1 and for x equals -1.
Wouldn't it be the same as right?
I don't know.
It would be.
Was that on the recording?
Yes.
Um,
So, but we don't know who it was. So we have here what Andrew would say that we're going to have the same, right? And even though we have positive and negative 1, when you square them, they both give you positive 1. And this negative is coming from here. Right here. So you all know that we will get plus minus the square root of 9, which will be plus minus, oh, sorry, y equals plus minus 3. Okay, but we got that with both values for x. So we're going to have 4 ordered pairs. Okay, so write down those combinations while I get the graph. And that one is actually going to be a circle. That one is a circle with the center at 0, 0, and the radius is the square root of 10, which is 3 point something. And then the other one is going to be an ellipse. An ellipse is like a circle that has it was vertically or horizontally stretched.
An oval?
An oval, yeah, there you go. We're going to study those and how to make them and all of their properties and Precal too. So how many intersections do we have?
4.
4. So then it makes sense that our solution set is going to contain 4 ordered pairs. So please, while you're doing your homework, if you're getting something wrong, please graph it and just see what's going on. You could also graph it on Desmos.
Or GeoGebra.
Or yes. Okay, so let's move on to the last one of the section. Okay. Now here it says solve by the addition method as well. So what could we do? You might think, well, we have different degrees for x, not for x. We have x squared, but here we have x squared and y to the first power. So we can still do it. It's not a problem. So I'm going to rearrange the first equation so it has this positive x squared is going to turn to negative x squared plus y is equal to 3. Second equation, nothing is going to change. And when it comes time to add, with the purpose of eliminating the x squared, we're going to respect the combining like terms rules. So the y squared and the y do not add each other, right, to each other. So we just write them like that.
So you're going to get it by quadratic?
So here's 12. So now we end up with a quadratic, right? So we equal to 0. So in this case, we'll move the positive 12 to the left. So y plus minus 4 and 3. So from here, quickly, we know that y will be negative 4 or y will be positive 3. So now we have the y values, so we need to solve for x. Well, we need to find x. So if I take this equation here, y equals x squared plus 3, and then I solve for x. So we will get y minus 3 is equal to x squared. We take the square root after that, and we're going to get plus minus the square root of y minus 3. So I want you guys to find the x numbers for for y equals negative 4 and also for y equals 3. Remember, this is where you're going to substitute. So we're trying to find x. Yeah. Yeah. Oh, for a card. Yeah, you could go write them if you want.
Just one more card from that one time I did something.
You can write one, and then another person can write the other one. That's okay. So we got that after substituting y with a -4, we got -7, and so we know that if the radicand is negative, then we automatically say no real solution. There is a solution, but with imaginary numbers. And if the solution has imaginary numbers, then we cannot physically see it. Therefore, it doesn't have a real solution. And the other one, if you substitute 3 for y, you will get the square root of 0, which is 0. So the only point that will give us the solution set will be one order pair with the coordinates 0, 3. So let me show you guys the picture of it.
Wait, you're not recording.
Yeah.
Oh, yeah, it is.
Okay. I forgot which one you were doing. Why? And the square plus 3. Okay, there you go. So if you guys notice, here the only intersection point was, and that's it. No more. 0, 3. Now, if you have a circle and a parabola, you could actually have 2 intersections, or you could even have you could even have like something like that. You could have a parabola like that. So you could even have 4 intersections, 1 intersection, or you could have no intersections at all. Imagine if the parabola was opening down like this. No intersection, so no solution.
Yeah, draw one with some points.
Maybe.
Could a parabola be like
Yes, definitely. It could be like that and then not intersect as well. Yes. 1 with 3, let's see. I don't know.
Like inside this.
Okay. Well, this is the end of the video. We're gonna try to throw one.